11.5, there's one more real quick thing that I wanted to go over. It should only take 2, 3, 4 minutes, something like that. And it is antilogs or anti-logarithm. So what we have going on here is anti-logarithm. It's the inverse of a log. So if we're talking log base 10, the anti-logarithm is the inverse of that. And we could express it like this. We could say that, well, log of x equals a, then we could re-express that as x equals the antilog of a. What's going on here is, how would you rewrite this as an exponential? Well, this is log base 10. So this is the same thing as 10 to the power of a equals x, right? Lesson 2, I think, we played around with rewriting or taking logarithmic expressions, writing them as exponential, and then exponential rewriting them as logarithmic. Well, guess what the antilog is? It is 10 to the whatever. So antilog of a is actually the same thing as 10 to the power of a. So what do we have here? We have x equals 10 to the a, x equals 10 to the a. Another way of looking at it is if you wanted to solve for x here, you would take the antilog of both sides. Antilog of the log, they cancel out. In much the same way like the inverse sine of sine cancels out. And you're just left with x equals antilog of a, or x equals 10 to the a. So your calculator probably does not have an antilog button. What it does have is a 10 to the x button, or a 10 to the power of button. Most likely that's the shift version of your log button. So like hit log or hit shift or second log, and that's your anti-log button, or your 10 to the power button. And this can be used among other things for solving things like if x is trapped inside of a logarithm and you can't use the like log on left side equals log on the right side kind of a thing. So if we have something like log of x plus 3 equals 2.5, we want to get at this x. It's trapped inside of the logarithm. We don't have a log on the other side. We can use the equality property of logarithms. So what would we do? We would take the antilog of both sides. So take the antilog of, on the left-hand side, antilog of the log. Those annihilate each other, and we're left with x plus 3 equals the antilog of 2.5. Well, antilog again is 10 to the power of, so it's 10 to the 2.5 power. So we're wanting to solve for x, so subtract 3 from both sides, so we get x equals 10 to the 2.5 minus 3. And then calculator to approximate that, we have 10 to the power of 2.5, and then subtract 3, so we get x is approximately 313.228. 313.228. We can check it, go back to our original problem, and I'm going to take the log of 313.228 plus 3, so 316.228. And I get something that is, my calculator has 2.500000321, basically the 2.5, because I rounded here, I'm not getting exact. So that's antilogs and what's going on with them, and a little bit of how to use them. So wanted to add that on to our lesson 11.5 discussion. Thanks.